Hi, today's video is going to be on ratios and proportions, and you should be somewhat familiar with these, so a lot of this is going to be review. We're going to start by just simply writing a ratio. Ratios can be written in lots of different ways. You can write a ratio as a fraction. We're going to write it with a colon. So if I want a ratio of boys to girls, and there are 20 boys and 30 girls, since boys to girls, boys need to come first, girls need to come second. So I have 20 boys to every 30 girls. But we have to keep going with that. We need to reduce that down as if it were a fraction. So if I were going to write it as a fraction, 20 over 30 reduces down to 2 over 3. So that's how I'm going to write it. It's a ratio of 2 to 3. So when it breaks down, there's 2 boys for every 3 girls. The next one we're going to write a ratio, still it's going to be boys to girls, but this time I'm telling you that there are 20 boys and there are 60 total. So I need the number of boys coming first. Given that there are 20, I didn't tell you how many girls there are. I'm not going to do 20 to 60 because I want boys to girls, but I can use this information to find out how many girls there are. So if 20 of them are boys and there are 60 total, this tells me that there are going to be 40 girls. 20 boys, 40 girls is going to give me 60 total. So we've got our 20 boys to our 40 girls. Again, if I were to write that as a fraction, what is that going to reduce down to? 2 over 4, yes, but that's going to go even further to 1 over 2. So when I write it as a ratio, it's 1 boy for every 2 girls. So we're going to write this in a ratio form with a colon. Ratios are sometimes written as fractions, but when I ask for a ratio of boys to girls or wins to losses, I want it to be written with the colon. All right, so now we're going to simplify the ratio, and our ratio is in fraction form this time. What we want to be careful about is when I look at this, I have 15 minutes over 55 seconds. I can't simplify a fraction if I have different units. So the first thing we're going to do is get the same unit of measurement. And the good thing is it doesn't matter if you convert from minutes to seconds or seconds to minutes. In the end, your answer is going to be the same, but one way is going to be easier than the other, because if you're making something larger or versus smaller, you're either going to be multiplying or you're going to be dividing. It's always easier and you're less likely to make mistakes if you end up having to multiply to get to this same unit of measurement. So if I wanted to convert seconds into minutes, I would have to divide because I'm making it into a bigger unit of measurement, so I'm going to have less of them. If I have 15 minutes and I convert that to seconds, I can multiply because minutes are bigger than seconds. Now we know that there are 60 seconds in every minute. So if I have 15 minutes, I have 15 minutes of 60 seconds. So I do 15 times 60, which is going to give us 900 seconds over 55 seconds. So we convert it to get that same unit, so I can't reduce if it's in minutes and seconds. I either need to get everything to minutes or everything to seconds. It's always easier if you convert so that you are multiplying. Now that we have the same unit of measurement, we can go ahead and simplify our fraction. We've got seconds over seconds, so it really doesn't matter. Those units cancel out. 900 over 55 is going to reduce down to 180 over 11. All right, next one, and these next two are a little bit more difficult. I'm given that 8x is equal to 20y. I want to find the ratio of x to y. So remember, we said that means that x is coming first to y second. When I rewrite that ratio as a fraction, whatever comes first is in the numerator, whatever comes second is the denominator. So what I want to do is I want to rewrite this piece so that x is on top by itself and y is on the bottom by itself. So if I rewrite this, 8x equals 20y, We want to get x by itself on top, y by itself on the bottom. It doesn't matter if we move the 8 first or we move the y first. Let's go ahead. Why not just isolate the x? So if I want to isolate the x, I get rid of the 8. And since it's 8 times x, to move it, I divide. So 8 divided by 8 gives me 1x. 20 over 8, I simplify that down to 5 over 2. Y. So now I'm almost there, but to have a ratio of x to y, I need x on top, y on the bottom. So right now I need to move the y from the right-hand side to the left-hand side. I have 5/2 times y, so to move it, I divide. Then I've got x over y is 5 over 2. So the ratio of x to y is 5 to 2. When we move on to the next one, we just want to be careful because notice how I still have 8x and 20y. But this time I want the ratio to be y to x instead of x to y. So this time I want my fraction to be y on top, x on the bottom. Still start off that same way. But again, this time I want y on top, so I want to get y on top here and move the x over. So I want to isolate that y. So we move the 20 this time. So instead of having 20 over 8, we've got 8 over 20, which is going to reduce down to 2 over 5. X equals just y. And if I want my ratio y to x, I want y on top, x on the bottom. So I need to move that x over. And 2 over 5 is equal to y over x. So the ratio of y to x is going to be 2 to 5. We will do more of those. The ratio of the angles in a triangle are 3 to 7. We've talked about the ratio of side lengths a lot. We've talked about ratios of angles. And if you remember, when we have a ratio, a lot of times all we did was add x's to it. So we did ratios of complementary angles, ratio of supplementary angles. So the ratio of the angles in a triangle, well, we know that in a triangle we have 3 angles, and those 3 angles equal 180 degrees. So if I had a triangle here, if it was in the ratio of 3 to 2 to 7, that's not right because it's not 3 degrees, 2 degrees, 7 degrees. It's in the ratio, so we just add x's to each of those. So 3x plus 2x plus 7x, those 3 angles have to give me 180 degrees total. So 3 plus 2 is 5 plus 7, 12x equals 180. We divide by 12, and we get x is equal to 15. Now we want to find the measure of each of those angles. So this is 3 times x. So 3 times 15 gives us 45. 2 times 15 gives us 30. And 7 times 15 is going to give us 105. So the 3 angles in a triangle that are in the ratio of 3 to 2 to 7 is a 45 degree angle, a 30 degree angle, and 105 degrees. Great, almost done. Now we're going to get into solving proportions. Now solving a proportion is what you get when you set 2 ratios or 2 fractions equal to each other. So one fraction equals the other fraction. To solve this, you are going to cross multiply. So we've got 2 times x is equal to 9 times 4. So that gives us 2x equals 36. We want to solve for x, so since it's 2 times x, to move it we divide. We get x is equal to 18. Number 8 is slightly harder. Still, we've got one fraction equal to another fraction, so we're going to cross multiply. So it's 10 times, notice I have this quantity x plus 2. If there's more than one number in the numerator or more than one number in the denominator, put parentheses around those. Those are going to be grouped together. So it's 10 times the quantity x plus 2, and then 9 times 4. The reason why this is going to matter with those parentheses, I'm distributing a 10 to both the x and the 2, so that gives us 10x plus 20 equals 36. We move the 20 over. 10x equals 16. Take 16 and divide it by 10, and we get that x is 1.6. All right, that is it for our ratios and proportions review.